Hello, this is Dr. Butler. This is AP Physics. I wanted to show a lesson that I was not able to find on a video for. So we are going to be talking about rotational kinematics with non-uniform angular acceleration. This is what do you do when you have an alpha of time function or an omega of time function or a theta of time function when you don't have, you can't use kinematic equations on the rotational or angular kinematic equations. So it is just like what we would do if you were to use calculus in linear motion. We are going to be using angular motion where the alpha is compared to acceleration, where the omega is compared to velocity, and where the theta is compared to position. So instead of having the acceleration function, instead of having the velocity function and the position function, you have one of the angular functions. All right? So first of all, I'm just going to relate what these mean. If you have a theta function and you want, if you take the derivative of that theta function, that is going to give you your omega, your velocity, which is what you would consider. If you have an omega function, if you take the derivative of that, that will give you your alpha function. So theta to omega to alpha. Acceleration, speed, and angle. We can go the opposite direction. If we have our alpha function and we want to know what the omega function is, we would have to take the integral of omega, the integral of our alpha function, dt equals omega, and the integral of our omega function equals our theta. Okay, so these are just the calculus versions of the what we would know from linear rotations. So let me take an example using these equations. I have made one example right here, which is kind of something that's a little trickier. But the angular velocity of a process control motor, whatever that is given by this function. So when you see function, you should automatically think of calculus. Omega equals 20 minus 1/2 t squared, radians per second. At what time does the motor reverse direction? A, and B, through what angle does the motor turn the instant it reverses direction? So first of all, we got to figure out, what does reverse direction mean? Well, that means that the motor is spinning. It's spinning, 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 spinning. At some point, it starts to spin the other direction. And in the middle, right when it reverses direction, it has stopped spinning. That is when your omega is 0. Okay, so the first part of this question really isn't a calculus question. We could do some calculus on it and try to figure out what time it is, but we don't need to. We just have to say when omega equals 0, what time it is. Okay, well, our omega is 20 minus 1/2 t squared. I am going to take the units out of it, and then we just solve for t. So we have 1/2 t squared equals 20, t squared equals 40, and our time then is the square root of 40, which is 6.32. 6.32 seconds. Well, we could do this. It's either 6.32 or minus 6.32, but we're not going to go back in the future. Okay, because of the square function. All right, so that's letter A, is 6.32. So B says through what angle does that go? Well, angle refers to our theta, which is right here. We want to know what theta is. So we are going to have to use the integral formula on this side over here. So the change in theta is going to equal the integral of our omega dt. So we now need to take our function and take the integral of it, which is the integral of 20 minus 1/2 t squared dt. So we need to take the integral of 20, and then we need to take the integral of 1/2 t squared. The integral of 20, because it is a constant, is just going to be 20t evaluated at 0 seconds, and then that's 6.32 seconds. And then we have to take the integral of 1/2 t squared, raise the power, t cubed, 1 over that power is going to be 1/6 t cubed, and we're going to evaluate that from 0 to 6.32. Now in calculus you would put constants in this, but if you evaluate it at the two ends of the integral, those constants will go away. So then we need to plug in the numbers. Now at 0, it's going to be 0. So we need to evaluate it at 6.32. So 20 times 6.32 minus 1/6 of 6.32 cubed minus what it's all at 0, which is just 0. So this is our final, and that's our initial. And we can solve all of these things, which is 20 times 6.32 equals 126.4 minus, in parentheses I'm going to do just in case, is 1/6, 1 divided by 6, times 6.32 to the cubed. Minus 0 gives us a 84.3 radians. The question says, what angle does it go through? And so we have to add one more trick to this. If we know we have our theta in radians is 8.43, what is it in degrees? Well, 8.43 radians. Our conversion factor is 6.28. 2 pi is 360 degrees. And so we take our 84.3. 84.3. Take our 84.3, times it by 360, divide it by 6.28, and it goes through a total of 4,830 degrees. How many degrees that had to go through to do that? There you go. This is a rotational kinematics with momentum. Rotational kinematics with non-uniform angular acceleration. Question.